want to now look at how can we rewrite the capital accumulation equation in per worker terms as a function of capital per worker and the parameters of the model. To describe how capital per worker evolves over time, we will do this with the Solow model without any population or labor growth and without any technological progress. So for this, now something to note here is we'll note something here that we will use the per worker. Now, what are we going to use for this? We will use the per worker production function. Per worker production function and savings is equal to investment identity, right? So these are the two things that we will use to get everything in terms of small k, because that's what you want as a function of k and parameters. Sorry, like let me just do this. We want it as a function of k and parameters, right? And savings is equal to investment identity, or to reduce everything in terms of k and parameters, right? So these are the two things we have to use to reduce everything in terms of k and parameters, which in this case are savings rate and depreciation rate and parameters. Right, so we don't want, basically the idea is that we don't want the equation to include, we don't want the equation to include I or Y, right? So we don't want these terms in it, right? So what you're going to use is the per worker production function, and savings is equal to investment identity for this purpose. So let's start with the capital accumulation equation, which in our basic Solow model, let's see how is that given. So we'll start with the capital accumulation equation. So the accumulation equation is kt plus 1, which is capital next period, is equal to investment this period, plus 1 minus delta kt. Obviously, another form of writing this is kt plus 1 minus kt is equal to it minus delta kt. Both are the same, it doesn't matter. You'd get the same answer regardless. So the first step is we'll use our saving investment identity. We will replace it, because it, like, the whole idea is that you want to get everything. So the whole idea is that you want to reduce everything in terms of k, right? So we're going to replace it as s by t. Right, that's the first step we're going to do. We're going to replace it with s by t, right? The whole idea is that you want to reduce everything in terms of k and parameters, right? That's the first thing that we're doing, and we know where does this come from. This investment saving identity comes under the assumption that we have a closed economy and there's no public saving, it minus g0. So under that, investments are equal to your private savings, and your private savings in this case are saving rate times output. So we can write this as kt plus 1 is equal to s by t plus 1 minus delta kt. So that's the first. Now, the second step is going to be, let's just clear all of this up. The second step, so we have this, right? So we just came up with this, kt plus 1 is equal to s by t plus 1 minus delta kt. The second step will be, let's divide both sides by n. Something to note here is that with k, with y, we have a time subscript t, but we don't have a time subscript divide both sides by n. Here, notice that we don't have a time subscript with n, we do have it like k and we do have y. This is because we are assuming n is fixed. We are assuming n is fixed. So it doesn't need a time index, right? We have this assumption without any population or labor growth. So it doesn't need a time index. Need a time index because we're looking at the basic Solow model, right? Where there is no population or labor growth. So that's why we do have a time subscript with k and we do have a time subscript with y, but we don't need one with n. So we can divide both sides by n, and this will become kt plus 1 by n is equal to syt by n plus 1 minus delta kt by n, right? Now the third step is going to be, let's rearrange it a bit. So we're going to rearrange it where we want to get it in the form of where we essentially want to bring this kt, we want to write it like this, right? Basically, because on the left hand side we want change in capital per worker, so we'll take a kt by n over here. So I just taken a part of this over here, so this becomes syt by n, and this becomes minus delta and it becomes KT by N, right? So we've just rearranged it a bit, right? Where because we know in the we want the capital accumulation equation per worker terms, we essentially want on the left hand side change in capital per worker, right? So that's why we can take a KT by F there. Now the fourth step is going to be, okay, we are going to replace, because again the whole idea is that we want to get everything in terms of K, right? So we're going to replace YT by N is equal to our per worker production function, which is like FKT by N, right? So we're going to replace this, right? So then we can have KT plus 1 by N minus KT by N is going to be equal to SF. So we're going to rewrite Y as a function, right? So this is a per worker. This is our like per worker production function, right? Output per worker is a function of capital per worker, the per worker production functions. We'll use our per worker production function. If we're given a functional form, we'll use that. We were just writing the generic form, Kef is a function of capital per worker. So we'll use that and we will replace that, because the whole goal is that you want everything in terms of Kn parameters minus delta KT by N. And then we have, so we have derived our per worker capital accumulation equation per worker terms. This is change in capital per worker, change in capital per worker from T to T plus 1, right? From T to T plus 1. This is investment per worker, but now it's purely in terms of capital per worker in your parameters. Investment per worker. This is our depreciation per worker, and this is sometimes also known as break-even investment per worker. Break-even investment per worker, right? So what we have done is, now we can see that everything, so we're done with our capital accumulation equation per worker terms as a function of Kn parameters. Everything is reduced in terms of small k, reduced in terms of small k, which is just our kt by n, and parameters now, right? And parameters. Now we reduce everything in terms of capital per worker. This is essentially delta k, right? Right, everything in terms of capital per worker, right? This is capital per worker next period, this is capital per worker this period, and in terms of our parameters S and delta.